Next, we're going to take a look at how to simplify variables under a radical. So we took a look at how to simplify the numbers under a radical. Variables work the same way. We want to find a perfect square factor of whatever is underneath the radical. So for our first example, x cubed, x squared is a perfect square. And remember our properties of exponents. X squared times x gives us x cubed. So we can split this up as the square root of x squared times x. Splitting it up further, we've got the square root of x squared times x. And remember that a square root and a square undo each other. They're what are called inverses. So if you take a number like 2, square it to get 4, and then take the square root, you get 2 back. The same thing happens with a variable. The square root of x squared is x, and then we have the x left over under the radical. Our next example, we have a number and a variable piece, so we'll review what we do when we've got that number. We're going to find the perfect square factor that goes into 700. In this case, 700 is 100 times 7, and the perfect square factors of c to the fourth are c squared times c squared. Remember, when we multiply powers, we add the exponents, so the 2 plus 2 gives us the 4 that we started with. I'm going to put all of my perfect squares first. So we've got the square root of 100, the square root of c squared, another square root of c squared, and then the one that's left over is our 7. So in order, I'm going to take the square root of each piece. The square root of 100 is 10. The square root of c squared is c. The square and the square root cancel. Same thing on our next one. We got another c times the square root of 7. Multiplying our c's together, we have 10 c squared times the square root of 7. Now let's take a look at what happens when you have a coefficient. The same process applies. We're just going to have that extra, in this case, times -8 after we take the square root of our perfect square factors. 24 is 4 times 6, 4 being our perfect square factor. H to the 7th. Basically what we're doing is if the number under the radical is odd, there will be 1 left over. If it's even, then it's a perfect square. So we can think about this as h squared times h squared times h squared. So far we have 6 h's being multiplied together, so there's 1 left over. Starting at the beginning, and again grouping all of my perfect squares together. So all of my h squareds are going to go in front of that 6. And then I'm going to multiply the 6 and the h that are left over together under one radical. Taking the square root of each piece, we've got -8 times 2 times h times h times h for the square root of h squared in each of those. And then the 6h is still left over. And finally, multiplying everything together, we've got -8 times 2 gives us -16. H times h times h is h cubed times the square root of 6h. One more. This time we've got not only a coefficient, we have a variable piece multiplied out front. Nothing's going to change with our process. That 9y squared will simply be multiplied by any perfect square factors we can cancel out. 27 is 9 times 3, y to the 10th. So here's another way to look at this. Instead of doing our adding rule, we can do our power of a power rule, which means we multiply the exponents. So y to the 10th is the same as y to the 5th squared. So we've got a perfect square factor in there. Again, splitting these up, we've got the square root of 9, square root of y to the 5th squared, and the square root of 3 is left over. Taking the square root of our perfect squares, we've got our 9y squared as our coefficient out front. The square root of 9 is 3. And remember, the square root and the square cancel on that next piece, leaving us with y to the 5th. And then we had a square root of 3 left over. Final step, multiplying everything all together. Multiply your coefficients. 9 times 3 is 27. And multiply your powers, which means we add the exponents. So we have y to the 7th with the square root of 3 left over. So remember, if you are having a hard time with your exponent rules, here we have 2 y's being multiplied together. Here we have 5 more y's being multiplied together for a total of 7 y's being multiplied all together. Finally, we have our error analysis, so make sure you're looking to see what mistake I made and fixing it. So we have our 11w as our coefficient. 16 is a perfect square, so I'm going to leave that under the radical. And for w to the 9th, I'm going to split it up as w to the 8th because 8 is an even number, and then there's 1 w left over. So next, I'm going to take the square root of 16, the square root of w to the 8th, I divide the power by 2, and then the last w is left over. Taking the square root of 4, I get 2 times w to the 4th with the square root of w left over. And finally, I'll multiply and get 2 times 11, which is 22. W times w to the 4th is w to the 5th with the square root of w left over. So find the mistake that I made. I made one mistake on this one. Make sure you find it, and we'll talk about it in class.